Yes.
Okay. All right. So folks can see it as well online. Bit of this is fine, but a week ago I was presenting at TUM. Okay, so I wanted to talk a little bit about the role of open standards, and some of the work that we've done was Chronos, Cesium, Bentley, Niantic, and others in shaping Gaussian splats specifically to GLTF. As you know, Gaussian splats have been a big topic the last year or two. There's a lot of products that are out there that are trying to, uh, yeah, it's good.
Yeah. So
No worries. That have been working. And yeah, I want to talk about that a little bit. And then also, GeoAI is another area in geospatial that has been taking big strides, and want to talk a little bit about that workflow. And then want to see how that would impact some of the works that we do. I skipped that part because you know me, I don't need to talk about it. It was another presentation. So one of the things that I've been noticing is that the 3D geospatial landscape has been shifting significantly. You have this traditional workflow where mesh capture, structure from motion, stereo, and texture mesh output was big. Still a big part of the workflow involves that. This is very computationally intense, large file sizes. There is a lot of struggle with capturing reality, vegetation, thin structures, reflective services. Has always been its Achilles heel. It's proven, but it still is a very limiting sort of workflow. And then there's this emerging paradigm today that we see, right? Nerves, Gaussian splatting, and neural radiance have actually.
we're all related.
Sorry? Oh, okay.
Mike.
Okay, Mike, that is not you, right? So there is a new emerging paradigm of being able to capture as fast as possible, and then without sacrificing or compromising a lot of the visual fidelity. And this is where Gaussian splatting and this whole area of nerves, neural radiance fields becomes very important. Now, the key thing about here is, it's point-based rendering, no connectivity of meshes. And the biggest thing is that, generating photorealistic results with extremely fast processing is very appealing. Oftentimes, it's also the cost involved in capturing these things that becomes very, very limiting. So this is a new 3D data type that is happening, and in GIS is evolving. And if we're talking about digital twins and that space, this is really an area that is pushing it. So where it really becomes interesting is this is infusing both AI and machine learning into the semantic understanding of the 3D content that we're working with. But the question then again, at least for geospatial, comes in: how do we leverage open standards to kind of keep up with this, what I call dual revolutions? The simplicity of the file formats, the capture access, and then also, keeping it open and interoperable is also big. I wouldn't delve about this too much, but I like this Arnaz's definition of what is Gaussian splatting. It's just a quick intro, just a new way of creating techniques from 3D content from photos. Basically, you have a collection of this anisotropic Gaussian primitives. What are those? Just a blob in space. He said. Sean and me revolving is a perfect definition of what Gaussian splat is. It's just a blob, and that blob has a position for X, Y, Z. It has this rotation in forms of quaternions, and then it has a scale and additional thing, opacity, And the thing that makes it, quite appealing from any angle is this view-dependent color. As I said, no connectivity, no mesh connectivity is required, and this significantly reduces the processing overhead. And then there is a photorealistic appearance that you get out of it. And it's a new data type in digital twins, and GIS is evolving highly. Here's an example of that, what it means. So traditionally, the video is choppy in this, but it's fine in here. Traditionally, it's been very difficult to capture, like, mesh type of structures, thin structures like this. There's an antenna on top of a building. If you think about photorealistic representations, these were artifacts typically. They would be, they would look really ugly, and then it wouldn't capture the visual fidelity of what the intent, or what the scene that you're capturing. Now this is a possibility, right? Vegetation on the right side that you're looking at here is also accurately captured, and glass facades, water, and metallic objects are really, really well captured. So that's the value that this brings, a new experience, if you will, in geospatial. Did I skip one slide or no? Here is an example of it in construction and AEC. This is from Stuttgart. Here, I know my friend earlier was was looking into construction workspace. So this is an active construction site. They want to update as they build, and again, they capture this very frequently, right, in matters of hours sometimes, so that they would reflect the change that is happening in the space. And this is again all possible because you can use it with your existing data. So you have a site, a plan, and then as the construction site evolves, you can easily and cheaply capture this new views and represent in your 3D workflows. So again, a new use case or a new way of representing data. But it is, and this is where open format standards come in. So this content is the new 3D Gaussian splatting representation in 3D tiles being displayed with existing base maps of vector data feature, whatever you have. Again, all of them working interoperably, right? You have your feature data, you have a BIM data, you have an imagery, everything coexisting and co-working together is really the future. Now, earlier there was asked, oh, how about I want to do analysis, whether I want to, put an object here or, whatever analysis that you might want to do within your workspace. This actually allows you, and the biggest appeal of Gaussian splat, at least for me, is that they are friendly for AI and ML manipulation, because again, the primitive is point-based primitive you have, and traditionally, if this was a mesh, for example, we'd have had to create another abstraction on top of that, whether it's a triangle, you either convert it to a line segment and then you segment that. So there was an indirection that needed to happen when you were working with AI and ML ecosystems, for example, that you need to do in traditional photogrammetric meshes. And here you don't need to. You can start discriminating on the point primitive itself. So my view is that open standards are the enablers for this cross-consortium kind of collaboration, and we see this day in and out. And GLTF and now the evolution of 3D dots is really a good example of that. When in geospatial, we've had bounding volume hierarchy and LOD replacement for a while. It's not new in this space, but we're taking that into, say, in the graphics world, where it came from in a way, but it's never had been standardized, right? Because game engines would have their own way of splitting and replacing content and whatnot. But it hasn't risen up to a level where it was standardized and different ecosystems could use it. So that's what we're hoping, that when a standard is just 3D tiles and becomes commonly adapted and used in other ecosystems as well, will enable collaboration in this just different areas. One area that maybe we can think about is gaming AEC digital twin. So uh, we have, many standards, many words, call it, where you have, geospatial ecosystem, and we have this standards that we all know, right? As referenced, massive scales and attributes and semantics are the focus of these things. But if you look in the gaming and 3D graphics world, you have the FBX, the USD, the GTFs, and here the concern is of visual reality or visual fidelity, real-time rendering, scene composition, and the likes. AAC, BIM, life cycle, facility management, those are like the kind of concerns that this ecosystems would worry about, but they all have the same need, you know, uh, graphics fidelity, performance, and all the things. Then digital twins and the metaverse, if you think about that, kind of uses everything, but it's sort of like mandate is to create this uh, immersive experiences, simulation, and collaboration. So each ecosystem evolved independently, but there is a gap, for geospatial ecosystem. This is the ultimate, like, CRS, or having the object being tied to the Earth space is the central theme, right? Because CRS is always central to it. The others, yeah, sometimes it might be there, but um, it's not really central to it. So the idea, the thinking that when we're working with Gaussian splats is that, oh, well, hopefully this is not going to repeat again, like, that this fragmentation where, the ecosystem will evolve on its own, and then there are commonality, but it's always hard to kind of fuse it and work together. And this is what we're trying to do, right? By bringing some of these features and 3D tiles to GLTF, for example. Did I skip another one? No. So the OGC community standards for massive 3D data streaming storage playing. So the idea of this bringing this hierarchical spatial index with the LOD structures that is optimized for web, mobile, and desktop really works across the board. What you see here on the right is a Gaussian splat representation of a very remote and inaccessible area with this full fidelity and both visual and geometric consistency. When geometric consistency, I mean the object that you are working and seeing is as it is represented in reality, right? Now, we organize these things in different data types, whether it's 3D objects, integrated mesh point. We have this distinct way of classifying our data that we work with, and Gaussian splat is the new addition here. But every layer is geo-referenced by design, right? Bringing native location location is really native to the content that we're working with. And now, as we see it, CZMJS, LotusGL, DeckGL, FME, ArcGIS ecosystem have all adapted this Gaussian splat representation in its GLTF format as referenced by 3D tiles, and having that in the open format content like 3D tiles has been very helpful, because again, we didn't need to reinvent anything. It was already open standard. We just extend that and work with it. So to talk a little bit about the Gaussian splat, so the KHR Gaussian splatting standard that we work with, again, CZM, Kronos, Niantic, and ourselves and others really had sort of like two components. Again, it's a cross-consortium collaboration. The Kronos Group, OGC, and all these individual organizations also worked in that. But the idea is simple, right? Have the base splatting, KHR Gaussian splatting extension that represents the splat data stored as a point primitive, and the basic stuff that I described earlier, position, all those stuff. And with the idea that it could be extensible in future. And already, so this has been already released, actually. It says Q2 26, but we just released the release candidate about a month ago, Sean, I think, or so. Um, so we started off with having like, okay, we'll have a base Gaussian splatting extension, KHR Gaussian splatting. That is the minimum. Again, it can be used in any ecosystem, in any environment. But then, for example, Geospatial really lean towards this compression from Niantic Spatial, the Gaussian splatting compression. Don't ask me about the naming. It's busy, that does work too. But it showed its evolution, right? We evolved around that because it gives you about 90% compression versus PLY, which is also another format that is used for storing Gaussians. And it's good enough, it's simple, it's easily extendable. And, we all revolved around that and, a 3D task that cesium generates, Esri generates have this additional compression, but it's actually an additional layer. If you're another industry and you didn't need the compression, I cannot imagine why. But if you wanted to use a different compression also, you have the ability to use a different compression. So this kind of shows that, designing and working in standards in such a way that is catering for almost, a majority of the users is very helpful because at first we had this bundle and there was some pushback like, oh, we want to use this and that, and we said, well, right, it makes sense. Let's split this up. There is a path for it. So that's just a path that I wanted to mention and share. It is already available. Again, we use it, and there are other compressions that are available also. I wanted to talk a little bit about like how this was, if you've worked with GLTF and worked in that ecosystem, this is very familiar. So there's the GLTF baseline splat extension that I just talked about. This is like the minimum common standard for if you want to represent your splat in GLTF. Obviously, can be extended in the future. But then it can have additional decoding, right? The SPZ is one example that we talked about. And this is similar to the other compression that we have had in GLTF, right? If you have GLTF, you can have Draco compression. You can have mesh opt compression as well. Different compressions that work on the compression level. And here is also a similar kind of structure that we have where the compression is kind of like, detached from the actual splatting encoding. Again, allowing more interoperability and standardization by building on existing open standards. This is more about to talk about what it really solves. But again, as geospatial enthusiasts, we advocate for geospatial, just recognizing that we work in a bigger ecosystem of other, or other interests as well. And especially when you're working across like code solution and open source, you really want to make sure that there is not that much fragmentation, right? And this is where, having standards like in OGC and others would really help by sort of like, I mean, the challenge still exists, right? I mean, you're trying to stream millions of splats at city scale. So we do have the experience of dealing with hierarchical LOD, spatial indexing, never forgetting that, the georeferencing or the native location information is really key. But the other concerns, compression, web and mobile deliverability is also a key. That is also a concern that is also present in other ecosystems. So just understanding that and working with allies, if you will, that, well, it's the same problem whether you're working with a Tiffany lamp that you're trying to show in an IKEA demo versus, city scale content that you're working in geospatial. Now I want to change gears a little bit to talk about a Geo AI. So how does this all enable from, Gaussian splats to Geo AI, I called it? Well, the theme is the same, right? One is about optimizing and capturing reality data, reality capture, and as optimal format with the least amount of artifacts. And the other one is really manipulating that and creating semantically intelligent content out of it. So one of the examples that I wanted just to show is sort of like some work that we did in 3D mesh segmentation and object recognition. Obviously you can use deep learning pipelines to extract, objects out of photogrammetric mesh. Again, with their limitation, with their building infrastructure that you're doing. And then you can also detect and classify within the data itself, identifying individual assets, whether it's antenna signals, vehicles, and whatnot. Um, Now, AI pipelines typically need structured attribute 3D data, and encoding some of those parameters that are required in the 3D data set itself. And we did some work in IPS, that what I was talking about here, kind of helps that workflow. But without having a standards rich data, the uh, AI operates blindly, in which case, you just don't want to throw out everything that you have into this models and try to figure it out. It's one way people do that, but really feeding it a highly enriched data, because we do have the semantics and all the information that we typically work. So here's one example. So maybe there's a video here that I can play. So using open vocabulary attribution and free-form search queries in a geospatial context, here's one example. So I have a city, and I would like to find buildings with AC on rooftop, right? This is a simple query-based search, and you can perform that. And you can find those buildings that have air conditioners on top. Now, this is could be done qualitatively also. Well, I want to find even buildings that are dilapidated and are in bad condition. Query that. Maybe I can upload even a photo to match it, and then be able to find those within my city. So, this semantic intelligence of the data requires attribution. You want to do it in sort of, this is the example is in Zurich, I think. I would like to see those old buildings in Zurich, though. I haven't seen them. It's interesting. And it enables really an entirely new way of querying 3D cities, right? Typically, where we query and do it is more like, attribute driven, database driven kind of. This is not database driven per se. This is visual data driven, and this is where the power of AI and Geo AI comes in, where you are mining almost all aspects of your data, not only the tabular information that is, buried in in databases. So, we're doing for time. Sorry. 5 minutes. Okay. So there's a loop back, right? There's the standards development and the AI feedback loop, what I call it. So, we're good at developing the standards that work with geospatial data, 3D TOS, CDGML, evolved over time. Of course, it wants to update at the most. I thought it was only Windows that used to do that, but now it's Mac. Sorry. So the key being that reach attribution is being always, will create this training data for a machine learning pipeline. So we have a lot of attribution that we've been creating in our content workflows and in our databases. I mean, as the geospatial ecosystem. And there are many formats that are out there that are actually trying to mine this and use it. And I think we should be able to benefit from that ecosystem. But one thing that I would like to stress is that, not forgetting the geospatial nativeness, which is our key ingredient in CRS, having coordinate reference systems be natively available in a lot of this is going to be key. Key for advancing some of the workflows that we work in, and basically we're being selfish to ourselves, because having that innately with the data is gonna really make it usable in all ecosystems. Okay, so one last thing I think I wanted to just sign up with this is, vision is like having this Geo AI powered digital twins based on open standards. Video that you see is sort of an example of that. This is again a city with information, whether it is simulation, sensors. In this case, it's also subsurface exploration of data or urban design, right? Urban planning. New development, new construction is going to be done, and then what are the analytical works that you do, and then not forgetting like new and emerging environment game engines, for example, where most of the emerging youth is very interested in working with. So I guess with that, I'll leave you. That was sort of two or three or four takeaways. Gaussian splatting has been transformative with the new 3D representative for geospatial, surpassing meshes for vegetation thin structures, and open standards are really critical to achieving this. And then tapping into Geo AI requires, rich standards, rich 3D data for mesh segmentation or object recognition. And then lastly, the convergence of Gaussian splat plus open standards plus open or GeoAI is powering the next generation of intelligent systems. So that I guess I put my presentation. So I guess questions, comments, happy to answer. Anyone?
Also,
Sure.
For the mesh segmentation.
Yeah.
Or have you started exploring that for Gaussian splats as well?
Yes, we have, and again, Gaussian splatting has been really enticing when it comes to object discrimination, and because again, as I said, with mesh data, for example, you had to really translate your triangles and whether you're using mesh CNN or any other convolution, you really needed to convert your representation into a primitive that was amenable for exploitation, if you will. Here, I think the Gaussians themselves, as this point primitive, have a very rich set of metadata that could be used. And one of the things that we've been looking at was, well, okay, it was much cheaper to convolute over this primitives as opposed to, the amount of work that you have to do, especially with the LODs and other stuff. Like with mesh data, that was a prohibitive thing. Where do you start, discriminating? Do you start with the highest LOD or the intermediate? Because there are different approaches where you do on the highest one and then you transfer that result. So it just became very, very tedious, if you will. Here it's easier, as we're not quite yet there having, that nirvana. Oh wow, everything is now, working, but it does have a promise, a huge promise where the segmentation of Gaussians would be, much more AI friendly than, say, with mesh, for example. So still working in progress, but I think it has a huge promise to be able to do that. Yeah, hopefully that answers.
Yeah.
If you have a solution, let me know. Okay.
So is the main thing that Gaussian splatting brings to the table the fidelity and the
Well, I would say yes, those two, but I think the cost of acquisition or creation of Gaussians or reality-based data is cheaper with Gaussians.
Okay.
And that could be the changing thing, because if you think about data acquisition 5 years ago, the cost of what acquiring this data would cost you was dramatically came down. But now with Gaussians even more, and the entry point could be your iPhone, it could be a very low end device compared to very specialized systems. So it's almost like, you think about it, it costs less to capture, it has better fidelity, and it looks great. So it's almost like, where was it all this time? Kind of reminds me the same thing with
It's more efficient as well.
and it's more efficient. Okay, now there's the catch. Okay, well, it has a ML component to it. You need to have that. The rendering is not as easy, or the consumption aspect of it. You're not just rendering just triangles in here. So it's got a little bit catch, but again, not worth it at all expense when you think about it. I was gonna say one thing that it reminds me is of where compressed textures are today versus 5-10 years ago. I'm a big proponent of the super compressed textures, where it's as small as a JPEG, but it's GPU native.
Yeah,
It's best of both worlds. So I think Gaussians are like that here, where it's incredibly visually rich, and it is absent all those artifacts that we lived with for many years.
yeah. That's cool.
Sure.
So you're saying that we can do this with a phone, because I was thinking, what are the sensor, the physical requirements?
It's photos, right? So to capture Gaussians,
There's an app from Niantic.
yeah,
You can install it and you can
Scaniverse is their product.
So
Yeah,
Niantic has done the compression, but also
they have also a product. Yeah,
link.
yeah. The compression was on a sort of like a
Required.
byproduct, which is a convenient byproduct. The Geospatial kind of topic. So
Yeah.
And there are others also, right, that do that. And but yes, the entry point has become lower, and this is where you'd expect, So the other thing, evolution that you see in Gaussians is in fields like movie making, for example. Completely different set of domain. Still finding, if a director could capture the scene in 3D with that higher fidelity, imagine it can place all the objects as they wish within the 3D scene itself and recapture. Shoot it like 1,000 times without really having to move any object, a single physical object. So it does that fidelity opens up a huge ecosystem. And so we're happy Geospatial is a participant in this, and for a change is not, trying to adapt, but we're trying to push as much as possible the frontier, if you will. Yeah.
Any other questions or comments before we end the session? Okay.
All right.
Hearing none.
Thank you.
Thanks, Tom.
All righty.